Hi everyone, we're CLIKA, and this is our engineering team. You know, sometimes you want other people's opinions, and sometimes you don't. We're making a video anyway, so let's get started. I'm Corbin.
I'm Ben.
I'm Jungmoo.
I'm Bar, and this is In My Biased Opinion, episode 0.
We are here to talk about a lot of things, and today we'll probably talk about TF Lite, the magic and horror of it.
TF Lite is a framework that lets you take your machine learning model and deploy it to an edge device. That's why it was designed. That's the idea behind the library. However, despite the fact that it's pretty full-featured and you can use it for a lot of stuff, using it can be a little bit painful. I don't know if you've had that experience before, but I found it was pretty tough to understand what was going on. And they don't have a lot of documentation, let's say.
Yeah. It feels like an isolated island, honestly. Like, you cannot get to it unless you're using TensorFlow, and that is horror by itself.
Despite it not having great documentation, TF Lite's still pretty much king, right, for mobile devices?
Yeah.
Like, if you say you have like some camera that's like out in the field that you want to put your machine learning model on, what do you have to do to go all the way from PyTorch to running that model in the field, and what's the worst part of that?
So in order to deploy your model to, let's say, CCTV camera, for instance, from PyTorch framework, you need to use Torch Onyx package currently and export your dynamic graph that was built in PyTorch framework into a static format, such as Onyx. So I think Onyx is the most popular format that people use.
Is that easy, though? Is it easy going from Onyx to TF Lite? Like, I've never tried it.
No, not really. There's this one open source project that I've tried, and that one is basically converting Onyx model back to TensorFlow, and it converts TensorFlow to TF Lite. That's how they exported it.
So you went from PyTorch to Onyx, then you're going from Onyx to TensorFlow, and then from TensorFlow converting it to TF Lite.
Yes. And TensorFlow to TF Lite is like officially supported by Google. It's like part of the framework, right? But Onyx to TensorFlow is like just a random project on GitHub.
Right. Yeah. It's kind of unfortunate that basically everyone builds these PyTorch models, but then the end point, the destination that everyone wants, is TF Lite, right? If you're putting it on some camera in the field, and it sounds like it's pretty difficult to actually go from that big PyTorch model all the way to TF Lite. And so when you do something like that, when you use an open source project, do you find there's like a big drop in accuracy, or do you find that like it kind of messes things up?
So yes, you are going to end up with some accuracy drops because like your original model was trained based on PyTorch framework, which might calculate things differently under the hood. So like your TF Lite deployed model from PyTorch is going to have some accuracy drop for sure. Even OpenVINO or Onyx runtime, especially like if it's integer 8 or you integer 8, you're going to have some accuracy drop.
Right.
So what you said is also the reason we see people on the forums going for, hey, my TensorFlow model doesn't work. The TF Lite model accuracy has degraded. The reason is you cannot just naively transfer because the computations would be different.
Yeah. So we were naturally interested in building a bridge that allows you to more directly just take your high-level model and output a nice compressed TF Lite model to file. So from an engineering perspective, we've worked pretty hard on that, and it was a significant challenge because you sort of have to figure out what is exactly TF Lite doing and then reproduce that in a way that you can predictably reverse engineer the output that you expect. And it definitely took us a while, but I think we've made a lot of progress, and now we basically support TF Lite completely. So what that means is that you can start with your high-level model, and we can actually compress it, and then we can write out a file we can write TF Lite, a TF Lite model directly to file, which then you can put on your refrigerator or your edge device or your Safari camera or whatever. And that seems like a really simple thing, but there was a lot of engineering that went into it. And it was kind of fun doing it because ultimately you really want to be, when you're in training or like, quantization aware training, you want to be in float space, but everything that's happening in TF Lite is integer non-differentiable. So figuring out how to make those two worlds talk to each other is an interesting project, and also how to do that while preserving accuracy. was very interesting and pretty enjoyable actually.
So you described every operator as like a bonbon.
Yeah, exactly. Yeah, it's like, you know, when you buy those like variety chocolates and like you bite into one and you know, I was like, oh, this one has alcohol. I'm like, oh, this one has nuts, and oh, I don't like this one.
Which one is the one with the most disgusting flavor?
Oh yeah. Like probably the softmax. Because how they do their exponential is this like truncated Taylor series, and then they have a barrel shifter that actually finds. So all these are math details, but it was very difficult to like follow the breadcrumbs to figure out what they were actually doing. So that would be like the one where it's like, I don't know, like a dried cranberry or something. Where it's like it's a fruit, but it's not even a good fruit, and it doesn't match with the chocolate. Yeah, that one was the most disgusting. But there were also ones that were just really, really nice, like, you know, the ones with like a little bit of like liqueur or something, where it's just like pleasant with a little alcoholic bite. Some of the ops maybe like multiplication or add, like those are just
yeah, it's cool.
Oh, it's cool. It's a little different, and it doesn't hurt me too much. So I can just move on. Yeah,
those were really like nice. I feel like
those were simple, easy to explain, easy to implement, and of course it spans the spectrum. So I kind of like that analogy actually, the box of chocolates analogy. It's
just like life. So I really. Like it took me a while, even after I joined CLIKA and started to work here. It took me a while to understand the concept like behind CLIKA. You explained like this kind of virtualization of the TF Lite using different tools, so you can be like aware to the hardware that's actually going to run those calculations, right? And what you did was actually like creating this virtualized space where you can replicate exactly the operation that will eventually actually gonna run on the hardware.
But it's what you want, right? Like you want to be training your model in an environment where the machine learning algorithm is operating similarly to how it's going to be operating in the field, because you don't care about running it on a GPU. You want to put it in your refrigerator. You want to put it on the subway. So it's important that you be able to bridge that gap, I think.